Okay, so I had a theory, an idea. Maybe it's just me. I think this would be fun for me to race the clock. And saying, I said just a second ago before I started the video, I want to do a very brief rundown of the chapters we covered, and let's see if I can hold myself to that. As a professor, I get a little logorrhea sometimes. I just ramble on and on. Sometimes some of you use that to your benefit and egg me on or ask me questions like, well, theoretically, I mean, not so much this semester so far, but sometimes that happens. You get the professor off on some tangent. That happens. But I was thinking I set a timer for myself. And that's not very interesting unless there are some stakes. So how about if I don't finish what I want to say about the chapter before the timer goes off? Per chapter, you get 2 points extra credit on the midterm. Okay, so you're like betting against me here a little bit. Is that a little more fun? Is 5 minutes good? Oh, you want it shorter? Let's do 4 minutes. All right, 4 minutes. No. 4 minutes per chapter. I'm going to go over chapter 3, just as in lightning speed, kind of lecture through what the topics are. And I have 4 minutes there. We'll do 4 minutes on chapter 4, lightning speed, through the topics. Maybe we should play it so that I can't quite cheat as much. So chapter 3, what do I have to cover? I have to cover the foundational theory. CM comes from CM and CVP comes from separating fixed and variable costs. Okay, and then I have to cover unit CM, how to calculate, CM ratio, how to calculate, and then using it for target profit. Target profit calculations. I have to cover margin of safety. I have to cover DOL. What else? Oh, got to make sure we get multi-product, including composite units, right? Okay, so what else in chapter 3? Anything else you want to pour in there to decrease the odds that I will beat you and deprive you of 2 extra credit points for chapter 3? Okay. Oh, I did not put break even. Okay, so I will include a separate talking about break even as a subcategory of target profit calculation. Good idea. Good point there. Thank you. Okay. Oh, thank you. Yeah. Special orders are in this chapter. Special order decisions, specifically floor and special order ceiling. Okay, I think the odds are in your favor at this point. Anything else you want to add? Really overkill here. All right, I have to cover that. Chapter 4. Should we start with that and then go to chapter 4 after that and say what I have to cover in 4 minutes? Yeah, that's probably fair. So it's not this boring beginning here. And we'll put, where's the timer at? We'll put this timer. We'll make sure it's not visible by me. Let's see, can it it shows it right here. All right, so let's try and hide it so I can't, play to the timer a little bit. There, it's not visible. It's on that screen, but the other screen window, there we go, is open, is on top of it. All right, so let's start that timer once I start it. There we go. All right, so chapter 3. All right, the theory of chapter 3 here is that once you take costs, remember, profit equals revenue, which is R dot minus cost, which is C dot. We're looking into the middle of that C. What's the dot in that C function, cost function? Once you say, well, some costs move with volume and some don't, so some are variable and some are fixed, it immediately tells you that, well, we have some costs that are VQ, and that happens to match our revenue, which is price per unit times quantity. And now we can start to play with this a little bit. So we have, really what we have is PQ minus VQ minus F, fixed costs here. And we can start to pull these Qs out and play games with it and start to do certain interesting things that help us with decisions that the firm has to make with the tool. We help those decisions with the tool of algebra now. And the key takeaway here is once you do that, once you pull out the Q, you end up with this price minus variable cost, which is unit contribution margin. So unit contribution is the unit's price minus its variable costs. And it's really useful because that's the flow through from selling that unit to help us cover fixed costs and get a profit that will help our firm grow, pay back its financiers, and spread its value to more customers in the future. Because that's how you calculate contribution margin. You can do it on a grand scale by leaving the Q in there. So total revenue minus total variable cost. And that's our total contribution margin. And the unit contribution margin is simply pulling that Q out. And what's inside the parentheses here, P minus V, is our unit contribution margin, like I just said. Now we have CM ratio. And what we do is instead of pulling just the Q out, we can pull a PQ out instead. Somebody hid the eraser so I would lose. All right, I'm on to you. All right, so we have PQ minus VQ minus F, and instead we're going to pull a PQ out, so that goes to 1, and that becomes this over PQ. Q's cancel out. V over P, we end up with, right? So we end up with PQ times 1 minus V over P, and I'm getting off on some tangent here. I'm going to lose. This is terrible. But the point is, once you go through that transformation, you can create what's in the parentheses as the CM ratio, 1 minus the variable cost ratio. And I never ask questions about the variable cost ratio. What we really do is, the way we typically calculate it instead is it's contribution margin over revenue. I'm not going to algebraically move from here to here at this point. I'm on the clock. Well, this is how we typically do it. Unit CM over unit price or total CM over total revenue. But the point is it's CM over revenue gives us our CM ratio. This is very useful for certain calculations we have to do. All right, so now let's talk about what do we get? We're here. Target profit calculations. All right, what's useful about unit CM and CM ratio is that it helps us figure out how much volume we have to produce to reach our target profit. A special case of which is a target profit of 0, which is break even. So we just take whatever we're trying to reach, target profit plus our fixed costs over unit CM to get us the units to target profit. I ain't nearly close enough. Whoa. All right, let me round this out real quick. Remember our lovely square? I was about to go over that. Whenever we get a contribution margin and our CM ratio, and we divide this numerator by either of those, we get either a quantity in units required for target profit or the revenue dollars required target profit, P times Q, right there. And you can move across by dividing or multiplying P, either in top or in bottom. And we have a special case of that, where we have no profit, no target profit, that's break even, just F over unit CM and F over CM ratio. Margin of safety, we'll define it here, and then I'll make one little note, which I think will earn you points. Margin of safety is the firm's current sales or budgeted sales. Sometimes it's phrased as, if the budgeted sales are this, what's the margin of safety? But it's some sales dollars or units minus the break-even point, minus your sales or in units or dollars required to break even. So how far are we from that break-even point is the idea. Or how far is this budgeted number we're talking about from that? And in these problems, when I ask them to you on the midterm, I'm almost always going to have an option, which is this honey trap of, hey, one of those is the break-even number. So in your calculations to get margin of safety, you have to calculate break-even because you need to subtract this revenue from that break-even number. And there's this very tempting option right there in the answer choices that is the break-even number. And you think to yourself, I've solved it. Great, I can move on. No, it's wrong. I'll get you. I got myself one of these days just a few weeks ago, right? I got one problem wrong because I got so excited. When we have multiple products, we're doing the same calculations, but we have to create a composite unit. We do that by creating a bundle of units based on the sales mix. Okay. We figure out the contribution margin of that bundle of units. We have our composite unit contribution margin right here. We also can use the CM ratio, and we can use the CM ratio to bypass that calculation. There's some questions in there that give you enough details to know that you need a composite unit, or it's a multi-product calculation, I should say. But they don't give you enough to get the whole table out there where you get product 1 has this CM, product 2 has this CM, and there's a sales ratio of this or whatever. But they give you the total revenue under that sales mix, the total variable costs under that sales mix, and the fixed costs required. And you can use that to figure out what the CM ratio is given the sales mix that's required, and just bypass all of the nitty-gritty composite unit stuff. That's the power of CM ratio for those kinds of problems. I think that's about what we got. Oh, DOL is total CM over profit, which helps us refer to what our ratio is going from this part of the contribution margin of sales, our income statement, to this part of the contribution margin income statement. What our fixed costs are. And between CM ratio and DOL, they tell us whether the firm is relying a lot on variable costs or a lot on fixed costs. And lastly, special orders. Key to special orders is this equation right here, P equals F over Q plus V. So what is the floor? The P here is the floor price that you, the manufacturer, are going to determine as the minimum you could sell this product for. Well, it's going to be your variable costs. You have to recoup your variable costs, plus whatever fixed costs there are for the order divided by the number of units in the order. So every unit has to pay its price of the fixed costs. The trouble is some of these fixed costs are in the form of lost contribution margin from regular paying customers, assuming we don't have enough capacity to fill the order. Is that ringing a bell? So great. We have some constrained resource decisions. Oh, we didn't even put that on there. Let's just zip past that. We need this number right here. That's the critical issue. We need unit contribution margin per unit of the constraint. And that helps us order the products. And we go through and we figure out in that order how well we are going to, or how many units of demand we're going to meet to maximize our profits. In this case, contribution margin. Great. Well, I went a little over. And I didn't say anything about the ceiling. Special order ceilings set by the buyer. Buyer's not going to buy a special order price that's higher than he or she would buy on the regular market. So the ceiling is always the regular price you're selling the product for. I'm not going to say, I'm here for a special order because I have this big order for you, and you're going to say, well, we'll charge you extra for that. No. I'm special. That's not how this works. Chapter 4. Let's put me on the clock again. All right, so I promised, let's see. Class wins 2 points extra credit. Okay, chapter 4. Let's do it again. What do we need to do? What do we need to cover here? We cover, let's talk about some PDOH rate, how to calculate that. That for sure. And I'll put in here a little bit of theory. That's where I get bogged down. That's where you got me last time. So sneaky, making me write that on my own volition. So we have PDOH rate. We're going to cover that. We're going to cover overhead control account. Overhead cost of jobs. Total cost of jobs. Unit cost of jobs. Talk about allocation of overhead. Talk about departmental rates. Talk about disposition of overhead control account. That's an old-timey word. What you do with it, how you dispose of it, how you finish it off. In this case, I'll use a better word. Closing out of overhead control account. 2 types. All right. Is that pitted against me enough there? Okay, ready?
You could increase the time.
Yes, yeah, I could. We'll see. We'll see how mean I feel. All right, so chapter 4 talks about job order costing. All right, so we're still in the idea of trying to figure out the C, cost function, but we're subdividing into how much does an individual job or order cost us, because we want to optimize those. We want to figure out which one most profitable so we can get more of those in the future and fewer of the ones that are least profitable. So we need to know how much each one costs. The problem with this is overhead. Direct costs, too far down. Direct costs we can trace to individual product units or individual jobs or orders. Overhead is over here, and we know it's product cost. We're doing it because we're supplying this product or service or manufacturing this good, but we can't trace it. So what do we do with it? We absorb it or allocate it or apply it. 3 A words that basically mean the same thing. Absorption costing here. Job order costing is the archetypal primary way we start to think about this. And we do that by taking our overall overhead, our budgeted overhead, keyword there, budgeted overhead, because PDOH stands for predetermined, so it's earlier when we budgeted things, we don't know the actual thing yet. Predetermined overhead rate. So our overhead costs, budget overhead costs over the budgeted cost driver. Cost driver is something that we can trace directly to individual product units, so we piggyback overhead onto those jobs or orders through the cost driver. I will tempt you to get it wrong. Whoop, cheated, sorry. I attempt you to get it wrong by giving you actual numbers. Do not calculate the PDOH rate with actual numbers on any of the questions. All right, we apply overhead then to each job based on the PDOH rate times the actual cost driver consumption of that job. It's pretty simple. That's nice. And then the overhead cost, that is the applied overhead, that's the overhead cost of the job. And so if the question is asking for that, you'll have to figure out how much overhead was applied. Some actual cost driver consumption times the PDOH rate. You might have to calculate the PDOH rate. And then, don't forget, if it's asking for the total job cost, you have to include the direct materials and direct labor. All this work we're doing, it's tons of work. Yeah, so hard. Not really that hard, but it's a number of steps we have to do to get overhead. Doesn't mean it's all done. We have a bunch of things that we could indeed trace to the jobs that we have to make sure we account for. And then we can divide them by the number of units in that job. So so-and-so ordered 50 units in their job. We have a certain amount of overhead costs. We have the direct materials for that. We have the direct labor for that. Divide it by 50. We get our unit cost for that job. Now, the way we trace overhead control, because we're kind of fictionally allocating it, is the overhead control account, sometimes called manufacturing overhead control or manufacturing overhead or overhead, whatever it is. The way it usually works is actual overhead costs are over here on the debit side and applied over here on the credit side. And they almost never match up because they're based on budgeted numbers versus actual numbers. And we don't know the future. Our budgets are never quite right. So there will be some imbalance. So we'll end up with a balance over here, more debits than credits, or more credits than debits. And we have to close that out. We can close it out to COGS, cost of goods sold directly, or we can close it out to work in process, finished goods, and cost of goods sold ratably based on the number of units in each of these. Sometimes it's based on the number of dollar amount or the dollar balance of each of these. If you want, I think all the problems I have in there talk about units. Say, oh, there are so many units work in process still. There's so many units that are finished but not sold, and so many units that were actually sold. And so you take those units, sum them, that's the denominator, and then the numerator is, got closer. The numerator is how many units there are for this individual account. So say there are 5 units in work in process, 5 units in finished goods, 10 units that were sold. So I have 5, 5, and 10, 20 total. 5 over 20, or 1/4 of our cost is going to be closed out to WIP. 5 over 20, or 1/4 is going to be closed out to finished goods. And 10 over 20, or 1/2 of it, is going to be closed out to cost of goods sold. Departmental rates. one way I can make the problem more difficult is to add departmental rates. And so each department takes all of its overhead and applies it based on its particular cost driver. Don't cross streams. Don't try and take one department's overhead and use it to figure out a PDOH rate on a different department. No. This department has this budgeted overhead. It uses this cost driver, and that's it. Second department uses a different amount of budget overhead based on that department's consumption of overhead, projected consumption of overhead, and a different cost driver based on that department's anticipated correlation between overhead and consumption of cost driver. Okay. Great. All right. Class wins again. I got close to this time. Did I make anybody nervous? Is that about as close as we got to something exciting in this class? Oh, I just burned myself. What am I doing? All right. So chapter 5. Now we have 2 weeks worth of stuff in chapter 5. So here is your trade-off. If I try and cram it all into one 4-minute period, I'm most certainly going to lose. So you get the 2 points kind of guaranteed. More guaranteed. But if we split it up, there's 4 points on the line. But I have more of a chance of actually making it. So let's put it to a vote. Do you want to cover chapter 5 all at once? Or across 2 different 4-minute sections? So all at once. The second one is 4 points. So 2 points, but probably get kind of guaranteed. Nobody's voting for that. So I'm guessing everybody is voting. Okay. Everybody wants it to split up. All right. So this is 5-1, which is a standard ABC, right? See, this is where I get to be the pool shark here. And I set you up to think I can't do it. And I take you for all your money. Doesn't really work as an analogy. Take you for all your extra credit points that you never had that I wasn't going to give you. Whatever. Stupid. Okay. So a little bit of theory. Have to do that. Talk about activity rates. So I know there are really what I need to do is I need to go through the different. I need to organize what I cover based on the different questions that I ask. Of course, I think that's what we do. So first stage allocation, activity rate calculations. Here. This is they kind of go together. First stage allocation, activity cost pools. So you can get after the first stage allocation. You calculate the activity rate, and then we have second stage allocation. Oh man, activity-based management. Okay, and I'll at least give a nod to the idea we can do a comprehensive. I'll go over the comprehensive kind of, not a problem, but what you might see in a comprehensive problem. So yeah, we'll make sure we cover that when we get to advanced. Some of you are rethinking your vote right now, I think. Maybe? No? Nothing I can do will make you nervous. All right. Ready to start? Me racing against the clock here? Yeah. No, it was chapter 3. All right. That's in 5-2, CCR, yeah. All right, I'll start the clock here. Okay, so activity-based costing says that was all well and good to piggyback overhead costs on one cost driver. What's better than one cost driver? Two cost drivers, or three, or four, or five, because there are multiple things that are correlated with overhead consumption. So multiple drivers that we can use as independent correlates to drive these overhead costs to the responsible jobs or orders, that thereby we can tell the profitability of those jobs and orders with more accuracy. So ABC, by definition, just based on the idea of adding predictors to a regression, always increases, at least by a very small fraction, the predictiveness of that regression. So ABC is designed to pick up on that and use multiple cost drivers. What it does is it says, well, the first thing it does is it says, let's get rid of this dotted line that was right here, where we're worried about product versus period costs. Anything that we can correlate to products is eligible. This is standard ABC. We're going to get rid of this dashed line here. And instead, all the Swiss cheese with all the holes missing is our period costs. We put them in the other category during first stage allocation. And instead we say, what is correlated with the different cost drivers we're expecting? In this case, 5 cost drivers leading to 5 cost pools. And we do that with a cost study at the beginning of ABC, where we develop this kind of a percentage table to say, all right, here are our general ledger accounts that are budgeted overhead costs. And we expect them, here they are, boom, 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 these three columns. And we expect them to correlate to these 2 activities. And then we have an other catch-all category there for the rest of the costs that are not associated with products. And we can multiply those general ledger numbers up there, 50,000 for shop supplies, 120,000 for machine maintenance workers' wages, or 85,000 for miscellaneous administrative costs, by those percentages, sum them at the bottom, and on the right-hand side. Yeah, in this example, I did it columns and rows reversed to how I usually set it up in the problems, if you've seen it that way. That's why I said summing the columns. Sorry. Summing this way in this example, we have over here on the right-hand side the totals. 137,250 for machining activity. That's our activity cost pool amount for machining. We have 46,500 as our activity cost pool amount for finishing, and that is what constitutes first stage allocation. And from there, we can calculate activity rates, which I think technically is part of first stage allocation, kind of the bridge between first and second stage allocation. This is our numerator. And machining has some cost driver. It's one of these, let's say it's number 1, machining activity, has some cost driver that justifies its existence. You can't have a cost pool without a cost driver, unless I went too far. What's wrong with me? Otherwise, it's a period cost. You can't drive it to product units and jobs and orders. And then we have different budgeted cost drivers we put in the denominator. Calculate our activity rates. We have the numerator right here. The denominator is right here. So we have the activity rate, which looks a lot like PDOH rate, just with the word activity pasted everywhere. Great. Some questions asked about that. Second stage allocation is suspiciously like departmental overhead rates. You take a job, you plow it through all the different consumables. It's a little like departmental overhead rates, but not quite. The point is, you take a job and it consumes all the activity drivers you're looking at, and you multiply the rates, charge it the rates that are associated with those activity drivers for its consumption. So much for my career in pool sharking. And that's second stage allocation. So now you have overhead costs to the job, and you've allocated those overhead costs now based on multiple activity drivers. And it almost by definition has to be more accurate, assuming you picked decent activity drivers. Activity-based management simply says, look, with that additional precision and accuracy of our overhead costs, and therefore our total costs, we can now make more refined decisions about which customers are most profitable, which product lines are most profitable, which potential improvements are most profitable. Those are the 3 that the questions tend to ask about, I think. There's one about a sales mix that's most profitable. And so we can now manage better our profitability, make decisions better based on more accurate numbers. That's activity-based management. So a number of questions asked about that. And sometimes I have you go through first stage allocation, which includes cost pools, getting those cost pools. And then I have you calculate the activity rates and then do the second stage allocation for a job. And sometimes I will ask you about, in this comprehensive problem, I'll ask you for the overhead cost of that job, which does not include the direct costs. Remember, those still exist. We still have things that we directly trace to, down. We still have direct materials and direct labor that we directly trace to jobs and orders. We're just changing how we do the overhead stuff. So some questions are going to ask you, do all those comprehensive, from beginning to end, activity-based costing stuff, and then figure out the overhead cost of a job or order. Others say, figure out the total cost of the job and order. So you have to add in the direct materials and direct labor costs in that instance. Okay, great. 5-2, maybe I'll make it up here. Maybe I will redeem myself and actually be not a loser every time. Technically, I've said you win. I'm 0 for 4 here. Over 3. All right, so we have, which one comes up first in the book? TDABC? Oh, wait. First of all, a little bit of theory. Why simplify, right? And then TDABC comes up first. TDABC, which includes CCR, and then activity rate calculations. And we can go over the idea of second stage allocation after that. Just review that it's basically the same. And we have approximated ABC. We have what we do differently in the first stage allocation. And then what, if any, is different in the second stage allocation. Anything else we want to talk about in this 5-2 section of the textbook? I was joking a little bit, but I think really this is where I might win. So don't throw anything at me to try to stop me from progressing, please. If you do, please make it something soft and non-injurious, or I will sue you. No, that was mostly a joke. Don't. All right, let's start. Okay, so ABC is definitely a complexification, to make a word, a way of increasing the complexity of our cost system. The idea is that it increases also our accuracy. It makes it more precise and accurate, but it definitely has more moving pieces. There are more drivers we have to trace. There are more cost pools we have to figure out. Why exactly costs move up and down is a little harder to explain to decision makers because there are more moving pieces. More opportunities for interdimensionality of these different dimensions we're measuring cost on. Each driver is a different dimension, right? Tell myself. So we might want to simplify it. And we can simplify it kind of two ways. One in which we simplify the first stage allocation, which is what we're doing with time-driven activity-based costing, and one in which we simplify the second stage allocation, which is what we do with approximated ABC, more or less. We also, the key is it's expensive to do both sections of this. It's expensive to get that percentage weight table through highly paid ABC consultants who are going to figure out what the relationship is between your GL accounts and responsibility of overhead. And it's expensive to keep tracing these drivers across time. Have a system that's going to, more robust software that's going to help you figure out the second stage allocation for each job or order. All right, so with time-driven activities costing, we're actually going to omit this Swiss cheese business all up here. All right, I kind of hung myself up on a problem at one point, I think last week, 2 weeks ago. 2 weeks ago, I think. Because I forgot. TDABC, we go back to the traditional idea of here are overhead costs, and we don't do the same percentage weight table. Instead, we say we're going to put all overhead costs in the numerator and divide them by some critical capacity, some practical capacity that's of importance to our business. So often we're talking about some sort of service firm. So we have doctor's hours or nurse hours or engineer hours, some practical capacity that really drives the value of our business. So overhead cost per hours of that important practical capacity gives us our capacity cost rate. So how much in overhead it costs for each hour of doctor time or nurse time or engineer time or whatever. And then our ABC study, our TD ABC study, instead of doing the percentage weight tables and everything, we say, all right, well, now all we need to do is figure out how much each of the different departments or process times or drivers is really what we're talking about, is consumed by or consumes of this critical capacity, this practical capacity here. And I give you these numbers. So the point is I give you, hey, here's how many of nurse hours or doctor's hours or engineers, whatever it is, that the XYZ activity takes, or the ABC activity takes, or the DEF activity takes, or whatever it is. And then you multiply the CCR by this number I give you to get your activity rates. So that's a very different first stage allocation than we have under traditional standard ABC. And it's simplified because it's all filtered through this practical capacity of this important person to our business, whoever they are. And the second stage allocation largely happens the same as usual. Now you have cost drivers, these activity drivers that are perhaps same in number as your standard ABC. And you can just charge jobs and orders as they consume those drivers. Right? Approximated ABC, we go through the whole first stage allocation as normal in standard ABC. But then we end up with, I don't know why I've leaned on it so much this semester. I usually don't, actually. We end up with this. You get your hopes up. It's a life lesson. Don't get your hopes up. We end up with survival of the fittest, where there's the low dollar cost pools, the little animals, and we have the high dollar cost pools, big animals, and the big animals eat the little animals. And they eat them in proportion to how big the big animals are to each other. So I'm putting two hands up here because usually we talk about most of my problems. I have you do two high dollar cost pools, like A and D in one of the problems. Like, A and D are the big ones, and they're going to eat all the little ones. And if A is like 75% of the, and D is 25% of the high dollar cost pools, then A is going to eat 75% of the little ones, and D is going to eat 25% of the little ones. And now we have new numbers for A and D cost pool, and we put that in the numerator over their activity driver. And now we have an activity rate based on just two activity drivers instead of 8, 9, whatever it is. So the reason we're doing that is it simplifies our second stage allocation. We only have to trace and track two cost drivers because we let the big ones eat the little ones. Did I cover everything there? So the differences in approximated ABC is not what you do up until you get activity cost pools. It's letting nature take its course after you get those numbers. You let the big ones eat the little ones, and you get new numbers. And second stage allocation works the same way as usual. Excuse me. Second stage allocation works differently. And I said it was simplifying second stage allocation because you only have so many surviving cost pools, right? You have the big dollar cost pools that are surviving. So it works the same way, I guess, in the sense that you're charging all the cost pools you have to jobs as they consume their drivers for those cost pools, but you have far fewer cost pools. So same general rhythm, but far simpler to set up. All right, you won that one. I'll give you that. Okay, 6-1. And that first we have, okay, same question. I think I know what the answer will be, especially given how I did not succeed in beating you in the two Chapter 5 quizzes. We split up Chapter 6 weighted average in two quizzes as well. Do you want those separate as well?
Yes.
Okay. All right. So this is weighted average TEU. So we need to cover a wee bit of theory. And what else are we talking about here? What is process costing? We need to cover units completed because you're often asked to do that as a play-in game in a playoff. Like It's not technically what I'm asking for, but you have to do that calculation to get what I'm asking for. Ending WIP equivalent units, and then TEU, which is the combination of those two. Oh, wow, we are pretty short. That's like it. You shouldn't have voted for this. Okay, I like your thinking. That's good. It's good prep for the possibility of losing to me.
You only have to technically beat you once in 6-1 or 2 to make up for 2 points anyway.
All right. Am I missing something? I'll just scrape my brain here, making sure I don't. Oh, you know what? No. Yes, we also have rates here. Yeah, I always forget how I split it up sometimes. So TEU and rates. All right, ready for the race? So process costing basically says, forget all this jazz about tracing things. If we've got something that's in a homogeneous and unchanging process, like the marbles I was talking about in my example, I don't know why I always default to that, but you're not going to name each marble as it goes across the conveyor belt. No, this marble's Johnny. This one's Fred. No, marble is a marble is a marble is a marble. And so you don't need to trace any of your product costs. Actually, it starts with the idea of, well, you don't need to trace overhead. Then you start to say, well, why am I even tracing direct materials, direct labor? They're all in this mass production, homogeneous environment. And so process costing says, let's simplify all that. And we end up with the idea that we're going to take basically total product costs over total equivalent units. Now, we can't quite do that because usually there's this non-uniform consumption of product costs. Is that the name of this lovely section? Yeah, non-uniform consumption of product costs. So we have two we typically do. We have direct materials over here and we have conversion costs over here. We have two different cost numerators and two different denominators for total equivalent units here. Equivalent units is the idea that we can't just rely on the physical units. We have to figure out what the equivalent units would be. Instead of having 10 units that were 50% complete, if we had concentrated all our time to get a full number of completed units, we could have concentrated our time and finished 5 full units, or 10 times 0.5, since they were 50% complete. So physical units times their percent complete gives us equivalent units. And that's important for ending work in process equivalent units. And we have also transferred in costs, which it doesn't factor into a lot of questions, but it's there just to remind you how this works in practice. The theory is we have some dollar amounts right here, and we need to figure out where they go. How much goes to ending work in process? How much goes to completed and transferred out? The units that were completed and transferred out. Over here, credited to our WIP account. I like to trace it using a department WIP account in units. And to get units complete, which I often ask you to, you take beginning WIP, physical units, plus units started, and subtract away ending WIP equivalent units. You end up with units complete. That nicely balances your T account. And it's just a beautiful thing. And then we use our TEU calculations here. Where are we at? TEU, total equivalent units, for the weighted average method here, is our completed units. We had to get units completed to figure that out. Plus our ending WIP equivalent units, which is our ending WIP physical units times their percent complete. So that is our TEU, our denominator for our rate. Usually we'll have a different number here for direct materials and conversion costs, which means that our TEU is going to be different for direct materials compared to conversion costs. And also, there are the questions that have direct materials are all out at the beginning of the process, like a paper airplane example, like we did in class. And they're 100% complete with respect to direct materials as soon as they're started and in process at all. So all ending WIP and beginning WIP units are 100% complete with respect to direct materials in that case. We also have the dumpling problems, which are all direct materials are added at, say, 50% complete with respect to conversion costs. So we see whether or not the conversion costs have passed that threshold. And if it's passed, then all those direct materials are all 100% complete. And if it's not, then the direct materials are 0% complete. Just as a reminder from a couple weeks ago. All right, great. And then we can figure out our numerator. which is total cost. But in weighted average, that means the beginning WIP cost, the beginning balance, plus the current period costs. So for example, we have 15,000 beginning WIP costs. We had a current period cost of 300,000. Then our total costs, our numerator, is going to be 315,000. I got closer that time. I'm not shifting my... I wanted to ask if I was trying to change my keyboard to a different language. It's pushing weird buttons. Yeah, Alt-Shift-5 is what you do for strike through in Google Sheets. So if you ever spend time making a list in Google Sheets and you want a quick way to mark something off, that's right. There you go. Life lesson. And you divide to get the rate. Oh man, I really was that close. You divide to get the rate. Okay, great. Near miss here. When you're sitting on a beach somewhere, enjoying those 2 extra credit points, just be grateful you almost didn't get them. All right, 6-2 is applying costs in weighted average. Okay, so we need to talk about, there's not a lot of theory to add to this. Oh, you know what? I can make up some theory here. Okay. It's not made up. I'm trying to make a joke there. So we have some theoretical backing for what we're doing, right? I'm going to go back to the weird GIF that I made that talks about where costs are going. We need to make sure we know ending WIP equivalent units. Ending WIP cost, and units completed and transferred out cost. I'll leave it. And we can talk about 2 ways of doing units completed and transferred out cost. We can talk about, I don't think I'm going to beat you on this one. Sorry.
You should just do a paper airplane demonstration.
I have to do it. I have to make a paper airplane myself. That's cruel. Why would you say that? No. So you can get, I know I asked comprehensive problems here, so maybe I'll discuss how I ask these kind of comprehensive problems. Yeah?
Is there going to be a question about how the 50% with respect to direct materials?
There are questions like that, and maybe I'll review how dumpling problems interact with this. How dumpling problems affect cost application. Kind of long-winded there, but I think we got it. All right, so let's try this. This is the boss level. Good luck. So now that we've completed our rates, which is in 6.4.1, we completed the rates. 6.4.2, we have step 3, which is cost allocation. So we figured out the rate for direct materials cost and conversion cost, and if we have them, transferred in costs as well. Which, one more time to review, we have our WIP dollar. This is the theory that's made up or not. And we have these dollar amounts right here, and we're trying to distribute them here and here. And our rates are going to help us do that. But the actual act of distributing them is what we're talking about right now. So the total of these two has to equal the total of this, or the T account wouldn't balance. And that's what it does. And also, if you remember, TEU equals units completed plus ending WIP equivalent units. Well, those just happen to be the two things we multiply our rate by to get these two sections here. So the algebra also tells you our rate is direct materials cost per equivalent unit, like right here. That's DM rate right here. And if we want to end up with just dollars, we want a dollar amount, we got to multiply by some equivalent unit number. So if we want dollar in ending WIP, we need to multiply this rate by ending WIP equivalent units. And those will cancel out. We end up DM dollars in ending WIP. We'll get that number right there. Likewise for conversion costs, take the rate and multiply it by the ending WIP equivalent units with respect to conversion costs. I didn't specify that was for direct materials, but it is. Ending WIP equivalent units with respect to conversion costs. We end up with dollars in ending WIP for conversion costs. Works out nice and pretty that way. Right? Okay. Now, with units completed and transferred out, it actually is easier because equivalent units equals physical units because they're units completed, which means 100% complete. So equivalent units is just physical units times 1. So by the identity rule in math, that means they're the same. And we end up with a rate times units completed equals the dollar amount for units completed with respect to direct materials in one case if we're doing the direct materials rate, and conversion cost rate times units completed equals the conversion cost of units completed. We can do that two or even 3 ways really, but we can combine. If we want to do 2 multiplications like that, we can add the rates together because they're going to be multiplied by the same units completed number. Because the unit completed isn't going to differ between conversion costs and direct materials. They're all 100% complete. So we can add together the rates in this case and multiply it once. DM plus conversion cost rate times units completed gives us the total cost of units completed. If it's asking for the total cost of units completed. So a comprehensive problem will start with enough information for you to figure out units completed so you can end up using total equivalent units and create a rate using the total costs that are also given. And then ask you to apply it to ending WIP or to units completed and transferred out.
If you don't provide units started, then it's one of those that cannot be determined, right? Or units added in.
I would need to I'd either need to provide units completed to you, or yes, give you units started is essential to figure it out yourself. Yeah.
Units started where the cost for the current period be equated to the same, then you have to have those 2 pieces, otherwise the same cannot be determined.
I see what you did there.
But no, in actuality, you really do need it otherwise, because I know they like to throw the trick ones in there. So when I was doing the practice, no matter what, if you don't have that started,
yes,
it's a unit cannot be determined.
Yes. There's one caveat here. If I might not give you enough right here, but if I've given you the rate,
right?
That might be maybe you said that. Is that what you said earlier?
Yeah.
Okay. So yeah. Then yes. Then it's just yes what you said.
Okay.
Yeah. Sometimes I don't give you enough to calculate the rate yourself, but I give you the rate, and so it's tempting to be like, well, I can't calculate the rate. But if you just look, I already gave you the rate. I told you what the rate is. Okay, dumpling problems. In fact, should we do one? We shouldn't do one. That's torture. Okay, well now that you've beat me a bunch, you're ready to be tortured. So okay. So we'll go into a problem maybe. We'll go into the midterm review. What are we? There. You can send Heather your thank you notes. You know, if that 2 points really makes a big difference to you, then thank her for it. There you go. I was about to finish. So let's do like if I had to for the midterm, the comprehensive dumpling problem variety is the hardest problem in my view, at least by percentages of how many students get them wrong. So it's an excellent one to go over if we only went over one problem this class period. And I don't have one here, so I'm going to redraw. It's not the hardest problem in the course because that is the FIFO version of that problem. It's a little harder. Not super hard. Don't want to make you freak out about it, but it's a little hard. There's an extra step or two. So like this right here?
Yeah, the next one is like
Oh, awesome. Okay. I mean, this gives us rate. This one, it does too. Okay, well, let's at least look at this kind of problem, so which will technically answer our question here: how dumping problems affect applying costs, if that helps. All right, so what we have here is we need to figure out the total cost of ending work in process. Total cost meaning we need direct materials and we need conversion costs. So we're going to need to use both of these rates. We can't add them together. Unlike a units completed problem, we're probably going to multiply the direct materials rate by ending WIP equivalent units with respect to direct materials, which is going to be different from ending WIP equivalent units with respect to conversion costs. So we can't just add them together because we're going to be multiplying them by different multiplicants, different factors in the product in our multiplication problem. All right, so let's write them down. This is our dumpling problem. And remember, we call it dumpling because when you're cooking dumplings, you do like half the work to get it all boiling, the water all boiling, and then you add the direct materials, the dumplings, like halfway through, and then finish the process. So before that, you just have a bunch of boiling water, none of which is direct materials. Nobody eats the boiling water. Or the pot, or anything else, the stove. That's all overhead and direct labor going into that. That's conversion costs up till 50% of the way, and then you add the direct materials, and then they're all added at that point. So that's the pattern that we have right here. All direct materials are added when units are 50% complete with respect to conversion costs. All right, so what that means is we can translate this beginning WIP, 39% complete, to mean that they are 0% complete with respect to direct materials. So they are not yet at that threshold in terms of the conversion process. The ending WIP units, though, they are at 80% complete with respect to conversion costs, which means they've passed the threshold at which you dump in the dumplings. So let's be complete about this. We have 157 physical units in ending WIP, and we have 0.8% completion with respect to conversion cost, and we have this decision rule, which says that if the conversion costs are greater than or equal to 0.5, they're at the 50% or past it, then direct materials are 100% complete, 1. Otherwise, they're 0% complete. They haven't passed the threshold yet. Okay, so that's our percent complete with respect to direct materials. Does that make sense what I did right there? I just put into Excel logic what I said out loud in words earlier. Okay, and I've done that before in class, so it's not going to be a surprise to you, I think. We can multiply out these, and we get ending WIP equivalent units with respect to conversion costs right here. And 157 times 1 gives us ending WIP equivalent units with respect to direct materials, if I could type. We can copy over from the problem. 25 is our DM rate. $16 is our conversion cost rate. And we can simply multiply. Well, let's put them in the same order throughout, just so I feel less disorganized. Okay, so this is our DM, cost in ending WIP, and the CC rate times the ending WIP equivalent units for CC gives us the CC in ending WIP, conversion cost in ending WIP. Okay, we took. Sorry, I had to flip them around because I put the rates in DM then CC, just like in the problem here. It's easier to map, I feel like. And so we have 157 ending WIP equivalent units with respect to direct materials times the direct materials rate of $25 per equivalent unit ends up with 3,925 direct materials costs in ending work in process. Conversion costs, same thing. We take the CC rate times the equivalent units in any WIP with respect to conversion cost, CC. And we end up with 2009.6. And the total of those two, and it did the wrong thing again. Google Sheets thinks it's so smart. Total cost in ending WIP. Great. Actually, this reminds me. I was on a this one paper, research paper about accounting, and we took a bunch of accounting exam questions and fed it into ChatGPT and see how well it did, and it didn't pass. It didn't do so bad, and certain questions did better than others. But I think the overall takeaway is, at least, well, I'll speak. I know for sure my questions, when I did it, there's a good number of co-authors who did this. With my questions, they didn't really pass. So I'm not surprised, Google. We have some real unique terminology we use in accounting that changes significantly the calculations that you do. It's to pass accounting classes, you have to build these detailed flowcharts in your brain of which arithmetic functions to do, and ChatGPT is better at limericks and poetry and making up silly stories or whatever. So this was a version 3.5, I think we did. There's a version 4 that's out now, or that is coming out, I think, or whatever. So perhaps newer versions are better at this kind of word problem specific to accounting. But I'm not too surprised. It was like, it doesn't know what to do with these because I'm using weird abbreviations. It's just looking at numbers and saying, well, maybe these are numbers that you want to add all together, all 4 of these. That's why it started out adding those all 4 together. So it doesn't know. And it's not even to the level of ChatGPT. So it's a very dumb algorithm. It's trying to decide what I mean, what I want, trying to predict what I want. All right, another weird tangent aside, that should be our answer there. Now, if it's different, if the problem's different. Yeah, so for example, like you're gonna ask, like, what happens if it isn't at the threshold? So 0.49, because I programmed it in, it's automatically gonna update. If the percent complete is not past that threshold, then our direct materials are 0% complete in ending WIP. So we end up with 0 equivalent units in ending WIP and 0 direct materials cost in ending WIP. And it ends up just being the conversion cost. Yeah, no problem. Yeah. No.
That's just for FIFO, right?
We will use that for FIFO. That'll be important in FIFO. But in weighted average here for the midterm and everything, nope. You get used to, for the next week and a half, ignoring that altogether. Yeah, the percent complete. We still do need the physical units. If I haven't given units completed or rate, you still use that, right? But this percent complete is always ignored in weighted average. Okay. Pull requests. What do we want to do? What do you want to look at? I think there's a very small percentage who have made an attempt at the midterm already. Maybe more in the online class than here in person. Yeah. Here's a good one. Yeah, exactly. So let me copy it down. First of all, let me undo what I did. And I can copy this down, put in the numbers, and it should give us the right answer. So just following that same second dumpling problem. Maybe you weren't asking me to do it, but I wanted to. So I think we got these rates copied over. We got the ending WIP units copied over, the percent complete copied over, and that logic still matches what's in the fact pattern up here. So I think we have 20 units of ending WIP equivalent units with respect to conversion cost and 0 with respect to direct materials. So we have 0 direct materials cost, and we have 260, which is the $13 rate times the 20 equivalent units in conversion cost. So total cost would be 260. We can double check that. Okay. Let's see. We answered just 2 questions. I think we just answered the 2 questions, right? So 2.5 times 2, we got 5. We got them right. Okay. Got a request for the last 6 minutes of class? Or is the request, let's go. Let's be done. You've broken our brains with enough extra credit points. You've broken our minds with your failures. My failure. Sorry. Yeah, that's a good one. Make sure we get that in there. It's one of those weird kind of off the wall ones sometimes. Let's see if we can get degree. Nope. So let's start over. Oh, is it DOL on some of them? Okay, let's see. All right, let's try again. If not, we'll go back to the actual chapter 3, and I think we'll have better odds. Well, that's funny. We had DOL, which is, anyway, for the wrong reason, it pulled it up. Great. Okay, so if I'm not mistaken, this is a problem. The problem that I got smoked with last time because I put in break even instead of margin of safety. So this was asking both for margin of safety and degree of operating leverage. So I can rule out some already. Remember in chapter 3 here, degree of operating leverage is contribution margin over profit. Yeah, there it is. Contribution margin over profit. So is that ever less than 1? The numerator looks bigger than the denominator, right? You would have to have negative fixed costs for the denominator to be bigger than the numerator. And there, I've made jokes about like, well, tell me that, give me some share in that business if you got negative fixed costs. So I can rule out A because it has a DOL less than 1, and I can rule out D here because it has a DOL less than 1. So I know the DOL is 2.667. Let's just make sure. We have 500,000 revenue. We have 100,000 variable costs, which means we have 400,000 total contribution margin. We take total contribution margin. No, let's stop there. We have 250,000 fixed costs, which means we have 150,000 profit. All right, so now we can say contribution margin divided by total profit. That's where we get our degree of operating leverage. So that's why we know it's either B or C here. And now we can say we have our CM ratio of 0.8. So CM ratio is always less than 1, unless you have negative variable costs. And we can divide fixed costs by that CM ratio. This is our break even in revenue dollars. You follow along what I've done there? I've said, here's our CM ratio. We earn 80 cents per dollar of revenue. It passes through variable costs. It passes through and contributes, I should say. 80 cents for every dollar of revenue that we have. And given that, we have to earn $312,500 in revenue to cover our fixed costs. Because 312.5 times 0.8 gives us 250 in the thousands here. Now that is not the answer. That's our break-even revenue. That's not our margin of safety. Our margin of safety is our revenue minus that number. That is our margin of safety. So that is how I get you. That's the right answer, not that one. Don't stop here and say, I got the right number. Great. All right, that was the margin of safety mostly, but we got direct degree of operating leverage. Is that good? Yeah? Okay. All right, well, I think that's good. If you got specific things you want to go over that you're having trouble with, please email me. I'll see if I can give you a specific recommendation on that. Otherwise, next week I'm going to treat it as office hours. I'm going to be in here available to help out with specific questions you have or you want to go over, but nobody's required to be here. You're spending plenty of time with your attempts at the midterm outside of class. Your attendance is not required next week, Monday or Wednesday.